Alrighty, I think we're connected. Happy Wednesday, and it's been what, a week and a half since we were here last on the 25th.
Yeah.
So hopefully you had a good Halloween. Do anything fun?
Took the kids to trick or treat.
Cool. Trick or treating is always fun. Got a little bit of rain on us, but it wasn't too bad. It was warmer than it has been lately, I think, for Halloween's, which was cool. Forgot I gotta get chat on my phone here. I didn't bring my other computer. And I've done good not eating most of the kids' candy. So I'll call that a win. Reconnect the chat for me. There it goes. All right. Make sure I'm on. Yep. All right. Cool. I'm on chat. So we'll talk about the midterm if you want. I can go over those long answer questions if you'd like to start. And then we've got to finish up array lists from chapter 12. And then we'll get into file IO. We're not going to do the entire file IO chapter. The chapter goes over two types of files. The first one being text-based files, which is what we're familiar with. And you open up a file, you can see the text inside of it. So all the stuff we've done so far in Java has been text-based files. Right? All of our .java files are text files. You can open them up and look at them. The other type of files are binary files, where there's some specific format of the way that the data is written to the file, and you can't open it just and look at the text, because there's not just text inside of it. So a real easy example of that, if we go find, where's documents, GitHub, and CIS 1500. If we look at our midterm review, right, the stuff in here, these Java files, are text files, right? We can open them in any text editor. Those are perfectly fine. A binary type file is, do we have any builds? Where's my builds? I don't have any builds here. If we generate, like the class files that get generated are binary files. That's the Java bytecode. We can't open them up in a text editor. So I'll just open that one up in NetBeans. And when we build it, we'll see those class files look like nonsense. Right? When we try to open them up, or like a Microsoft Word document, if you start a new Word document here, and you open that one up, let's call that test. In Word, it makes perfect sense, because the Word program, the application here, knows how to read and write its file types. Right? It understands what it's putting where and how to read that data out specifically. But if I just say, like, open this with Notepad, as just a plain text editor, it looks like garbage. Now, there are some actual spaces here that have text, right, that we can read, like Word document XML, Word web settings XML. So it doesn't mean there's not text in here. It just means the way that it's formatted, most of it's not text. It's anything we're putting in here. And all of that binary type data, we're going to not touch. We're not going to do anything with. You'll pick that up next semester if you do continue on in 2151. You'll learn more all about that. Binary files are great. They're actually pretty easy in terms of working with stuff. Getting everything out to text and then loading something from text is a little bit tedious. So being able to do that in a binary format is actually really nice, but there's a way to do it that is a little bit more complex than we want to tackle. So we're just going to skip it and say, well, we'll do that next semester. We'll do some basic file IO stuff. Let me close out all this here. What's that one? What's that one? What's this one? Oh, I'll leave that one for now. So we had our midterm review for the one. Do you want to look at those long answer questions for the midterm, or were those ones okay? Yeah, for sure. Let me pull up those. We had the three questions, right? We had the loop question, we had the method question, and then we had the class question, right? Quizzes. There we go. Oh, only 11 people did project 3. That's less than that took the midterm. So I wasn't going to go over the short answer questions. If you have questions about those, happy to look at them individually, but they're from a question bank. So like if I show them up here, I'm going to get a different sample than you guys got. So it probably won't make a lot of sense to look at those. So our first loop question, right? Enter items they want to add to a shopping list, and they can keep on going until they're done. Okay, cool. So two different ways of doing that, right? One being this sort of sentinel loop, like, hey, you give me something or the word all done, and I'll stop adding items to your list with a sentinel value. Or we have two different prompts, one for the item and one for do you have more, yes or no. Either one of those is perfectly okay, right? It just depends on which style loop you wanted to write here. So we've got the sentinel value loop here. We can do the other one, like string more items equals yes, and while more items dot equals ignore case. If it equals a y, we want to keep on going. We'll ask them enter an item for your shopping list. And then really we don't actually care what that item is, because we're not going to do anything with it. It'd be nice to do something with it later, but maybe like write it to a file. But we're not there yet. So this was just the loop. So keyboard.nextLine, and we never do anything with this item, but that's fine. And then we'll ask them, do you have more items? To add, and again, like tell them, hey, give me a Y or an N or something. Anytime you're prompting them and you're looking for something specific, we should tell them, hey, I'm looking for this, that sort of thing. And we can say more items. Keyboard.nextLine. Cool. So again, this is two different prompts, and that's okay. I usually like these sort of sentinel value prompts, but either one gets the job done. Not too big of a deal. Okay. And then for our sum of even numbers up to n, int number, give the sum of all even numbers from 1 to number, including the number. Well, starting at 1 is kind of silly, right? Because we know 1 is odd, so sure. But we'll write that as a function. So public static int, right? If we're going to return a value here, sum of even numbers up to n, given an int number. So I need a sum, right? I need a place to store the sum. We're going to start the sum off at 0, and then we're going to say for int, I don't know, how about like value? We already have the word number here, so I'm going to say like value. Now, two ways to do this. One is the short, easy way, and one is the slightly harder way, but still, like, it's one extra line of code. So the easy way is to start at 2, and we say as long as value is less than or equal to number, we take value plus equal to for our update. If you add 2 every time, you're always even. We don't need to check to see if you're even. And then I can just take my sum plus equal to value. Right? And when we're done, we can return the sum. That's the easy way. I don't expect most people to get this one, and that's okay. Like, it's not really all that much worse to do it the slightly harder way, which we, like most for loops, we say int value. Usually we start at 0, because why not? Value is less than or equal to number, value plus plus. And then we would say if value mod 2 is 0, it's even, then we'll take the sum and add it. Right? This is what I expected most people to check. Like, hey, if the number's even, add it, and then just add 1 every time. You're doing more work than you need to, but sure. Like, there's nothing wrong with it. It will still give you the right answer. Right? Yeah.
What is mod?
Modulus. So doing the division and getting the integer remainder.
Okay.
So it's one of the operators we looked at a while back in chapter 2, I think, when we looked at all the different arithmetic. So we say divide it out by 2 and give me the integer remainder. So if you can divide out by 2 and not have a remainder, if your remainder is 0, you must be even. This is our check for that. And then when we're done, we just give them back the sum. Okay, that one all right? And then the last one, we're going to write a class, a talking stuffed animal. I bumped it. Bumped my adapter. I lost the projector. There it goes. Okay. I will move my mouse over a little more. Like that. I feel like the cord shouldn't be that sensitive, but maybe it's my laptop and I should just get a new one. I probably have to do that. It's got to be really important, right? All right, talking stuffed animal. It has attributes for name, color, sound to make, and battery has power. We're going to have a constructor that takes values for name, color, sound to make, and have it set the battery has power to true. So like when you make a new stuffed animal, we're going to assume you put a new battery in it. which is probably nice. You don't want to make a talking animal and have no battery. You'll just make kids sad, right? And then they're not going to buy your stuff. Well, if get methods for name, color, and battery has power, we're not having a method for sound to make as a get method. Right? The only way to get that sound to make is through this squeeze method that 9 out of 10 times will give you the noise that it makes. 1 out of 10 times it kills the battery, because we might make cheap toys. We're that people. But you can also change the battery, and that will set the battery has power to true. Okay, so private attributes, a public constructor, public methods, ways of interacting with it. So this is our talking stuffed animal. So we're going to go and add a new class, talking stuffed animal, talking stuffed animal. So we're going to do our attributes first, and then we're going to let most of the code get written for us, which is nice. Oops, missed some of that. We're going to have a private string for name. We're going to have a private string for color. Wait, was it color? No, it wasn't. Name, color. Yeah, name, color, sound to make. Private string for sound to make. And a private boolean for battery has power. Okay, once we got those, let's let NetBeans write most of the code for us. So the constructor now takes everything except battery has power. So you give me a name, a color, and a sound to make. I'll set those values, but then I also need to make sure battery has power gets set to true. Right? So you tell me what the name of the stuffed animal is, you tell me what color the stuffed animal is, you tell me the sound that it makes. Those can't change now. Right? I guess you could technically rename your stuffed animal, but this is probably like the actual name of the animal, and not like what your kid calls the animal. Because kids name stuffed animals the weirdest things. My daughter has one she calls Poppin'. I don't know where that came from. It's a little bear, but it's been Poppin' for years and years and years, and it's still like her favorite animal. It's cute. And he's nice and like bright blue. It's a weird looking bear, but it doesn't make any sound though, but that's okay. So again, battery has power, we're setting to true. So this one doesn't come through the constructor. Right? The constructor's job is to give values to all of your attributes. So if I need to be given some, I take some. If I know what the defaults are, I take those defaults. Then we need some get methods. Right? We're going to have get methods for everything except sound to make. Again, that idea of sound to make, we're just going to get off that squeeze method rather than a get method here. So get name, get color, battery, and then is battery has power. Is anytime it's a boolean, it goes to is instead of get just by default. So that's fine. Just leave it alone. It just sounds funny.
Yeah, I was confused about that.
It's just a weird naming thing, because generally you don't get a true or false. It's just is true or is false. Mm-hmm. So the word they use is instead of get. Either way is fine. I'm not. I prefer just following this convention because it does it for me. Right, and then we're going to have change battery. So public void change battery. Change battery would take our battery has power and set it to true. That's all it has to do. Like, you can change a good working battery if you want. We are more than happy to, yes, the battery still works, even if it was already true. We're not like flipping from true to false or flipping from false to true. We're just, no matter what, we're just putting it to true. You put a brand new battery in here, it just goes. Right, and the last one then was squeeze. And squeeze returned a string here. Right, it's either, sorry, 734. Usually U of M. Squeeze is going to pick the random number first. So we need to do the random number generator. I prefer using this random class. You can use math.random as well, but then you have to like cast things as integers, and I feel like that's obnoxious. I mean, I guess this is an extra line to make the constructor, but so we'll have an int for number. Oh, we got to add our import. We'll say random.nextInt, and you give it how high you want the number to go. So random nextInt 10 will give me 0 to 9, so I want to add 1 to it to get 1 to 10. Not all that important, because we've said, hey, if the number is 1, do something. So if you didn't add a 1, you'd still have 0 to 9, you'd still have 1 out of 10 chances for this to happen. If we were looking for the number 10, and you did random nextInt 10, you would never get 10 without adding a 1 to it, because you get up to but not including this number. It's just a little obnoxious thing. Same with the math random, right? You have to multiply by something and then round it, and it's a whole process. But looking for the number 1, sure, it's within this range, but 10, we'd have to make sure we're adding the 1 to get a 1 to 10. And we'd say, hey, if number is equal to 1, my battery has power, it's false. Ran out of batteries. Right, that was just our little chance that, hey, we used up all the battery here. We don't even need to like count, hey, we got so many uses out of it. It just randomly happens because batteries are jerks like that. There's probably some logic behind it and physics and like chemistry as well. Batteries are chemistry, right? In sciences. There's a lot of overlap with physics though. But great. So whether or not we lost the battery, great. Now we need to see if we have battery. So if battery has power, now a lot of people like to say if battery has power equal true. This is too much typing, right? Be lazy, right? This already is a true or false value. So if I'm looking to see if it's true, I just say if battery has power. That's already a true or false. This if block will run. Here, I don't need to say does a true value equal true. That's more typing than I need to do. If it does have power, I'm going to return the sound to make. If it doesn't, you could have an else, but again, if you hit a return, your function, your method stops. Right? There's no need to keep that from also happening, also running something else, because if it hit a return, we're done. There's nothing. It's never going to run this next line. So there's nothing wrong with the else, but again, it's more typing than you need to, and take the lazy route. So if it's not true, this doesn't run. So then we'll just give back an empty string. We say we don't make any noise. Maybe you make one of those weird like low pitch like noises, but that's a little harder to type. So. And eventually it just totally stops. My little guy has an Elmo whose battery is almost dead, and it's like creepy Elmo now, and he thinks it's the funniest thing in the world. It's like you squeeze it, and you're supposed to say Elmo loves you, and this is like Elmo, and it doesn't even get the whole thing out. But he's like, oh yay Elmo! Elmo. It's like Demon Elmo or something. It's awful. But that is probably why I have a talking stuffed animal question for the midterm, because of that terrible Elmo, by the way. All right. My daughter had a half day at school today, and she's already home. Like, why do you even bother with half days in high school? It's such a waste. Like, so my senior year, every day for me was a half day, because I had a co-op job. So my 5th and 6th hour were the co-op job. And then my 4th hour, I was dual enrolled, so I would go take class actually here at OCC, which was a night class, because that was when they were doing the class. So every day was a half day for me my senior year. It was amazing. It would have been better if it was the second half, though, because then I could have slept in. I had still to get up super early and do the first half, but that's fine. I guess somehow you get used to getting up early for a while, but I got into computers so I would not have to get up that early ever again. And now I have to get up early to get my daughter ready for school. Okay, so that's our talking stuffed animal. Again, we didn't have to do anything other than the class here. If you wanted to use it in your main method, go for it and play with it, see if it does the things it's supposed to do. If you wanted to write unit tests, great. It's actually pretty hard to unit test something that uses random values, because it's a random value. There's ways around this that we just haven't gotten to yet and really aren't going to make any sense till your second or third programming course, if you're dealing with random values. We could like put it in a loop and call squeeze 100 times and figure if we call it 100 times, eventually we're going to get back an empty string, because the odds of us not getting a 1 after 100 times at a 1 in 10 are pretty low, but there's still a chance that it would fail. And if your test can just fail sporadically, it's bad news. It makes it a less useful test. And then in the real world, if it sometimes works and sometimes fails, people are going to ignore when it fails when they shouldn't ignore that it failed. And it can cause all sorts of issues. So, and there's ways around this. We don't know really how to work about that yet. So, okay, we feel okay for the midterm. Hopefully that was low stress, no time limit. I think that's a better model, and I'm just going to trust people not to cheat on things, because it's just not worth it. It's not. I don't like sit and watch people take tests. And then people have test anxiety, and whether or not you could do something in 15 minutes or 2 hours is not really all that important in the real world in the industry. I mean, yes, you have to get stuff done and you only have so much time, but generally you get faster at things as you have more experience. And you guys have been doing this for eight weeks now. So to say, hey, do this in a 2-hour sitting while I sit and watch you is no fun. So hopefully that worked out well. All right, so I can go ahead, I'll commit that here, and then we'll finish up our array lists. And then we'll talk about files, and then we'll talk about the last project. It won't be so bad, I promise. I promise. Midterm solutions. What, like a chair noise? A pipe? Someone out in the hall talking? Hearing things. I've heard that noise before, though. Like, I wonder if it's like one of the doors, because we're like right by the outer doors here or something. I don't know. Not sure. Oh, I forgot to watch chat. Oh, hey, Dodo. All right. Someone who's not in our class is the only person talking in chat, so okay. I guess that's what it is. Interestingly, though, our online courses are filling the fastest for winter semester, looking at online versus in-person classes. That still seems to be the trend. I'm guessing it's going to be here to stay, and it's not just because of this global pandemic thing. I think more people prefer that flexibility. I hate it myself. I never did well in online classes. Having more time. Mm-hmm. Yes. That's a hike. Yep. It's, I think, 16 minutes if I don't hit traffic, from what I can tell. If I hit traffic, though, on 96 or 696, it's just a crapshoot. Because I'm right on Maple, so like I shoot Maple to Wixom to get on the freeway. So it's like 3.5 miles to get to the freeway, and then it's all freeway to here.
I calculated it, but every week I drive probably 7 hours to get to classes. Okay. So if that was all online, that's 7 hours.
Yeah.
More time, but I do like in-person classes more. Yeah.
So I focus better if I'm in a classroom, because there's just too many distractions. I'm very distractible. I'm sure you guys have noticed. Dodo says he's an hour and a half away from school. Yeah, but face-to-face is a little more disciplined. Yeah, and I like to ask questions, too. I hate having to like send an email and then wait. Also impatient and distractible. Yep. All right, so let's close this one down. And we'll open up our arrays. Oh, did I not hit save? Any more changes? Oh. Oh, I formatted. Sure. Why does that look different? Just a couple white space changes. All right, and then we'll open up our arrays project. So the basic arrays that we've done are a little bit obnoxious because remember, you have to tell them how big they are. And that's either coded into our program or asking the user, right? So it can be like dynamic in that someone can tell me how big to size it, but once it's sized, we're stuck. And if they want to add more things, we can't do it. Right? Or to do it, you'd have to make a new array and copy things over by hand. So technically, you can make a bigger array, copy things over, and then use the bigger array. But that's a big pain. So the nicer way of doing things like this is by using something called an array list. So the array list is built into the Java library. So we'll say it's a array list is the class name. Now, it uses this funky notation. It uses this diamond notation here, a greater than less than sign. We say it's an array list of type what? So what type of data are we going to store? Where we did basic arrays, it was like, hey, it's an integer array. So in here, I'm going to say integer, the capital I integer class. The funny thing about Arraylist is you can't put in these primitive types. You can't put in ints, you can't put in doubles, you can't put in floats. You have to put in the class type of it. Remember, we have all these classes like integer capital I or double capital D that have methods that we can do fun things with. Well, we also need to use them in Arraylists to store that type here. So can't use int, double, float, char, those sort of things. We use the class version. And we'll just call this, I don't know, array list numbers equals a new array list. No, array list. And then the funny thing is when you use the second time, you don't need to tell it what type it is because Java says, oh, you already told me over here, you don't need to tell me again. Sometimes you'll see it that way. Well, they'll put it in a second time. And then it's going to tell you, oh, hey, that's redundant. You don't need to as a little hint here. It's going to say, hey, redundant type argument in new expression, use the diamond operator. So it says, you don't need to tell me it's an integer because you already told me it's an integer. I'm just saving a little bit of typing here. So it's fine to have it in there, but you don't need it there. Hey, Professor Burp, thanks for coming along. Yeah, online exams are hard, but the research that's been going around in academia says if your online tests are lower stakes, people are less likely to cheat. If you give them a test and say this is 40% of your grade, you're almost incentivizing people to cheat because if they screw it up, they fail the class, essentially. So if you have a smaller test that with less pressure, lower stakes, they're like, oh, I can probably do this and I'll be fine. People are weird like that. And asking them not to cheat at the beginning of the test makes it more likely they won't cheat rather than at the end of the test asking them, hey, by the way, tell me you didn't cheat on the test. That was another study they did out of one of the Ivy League schools. Like they had a whole sample of these things. It was like crazy behavior. But if you ask them first, it kind of puts you into the mindset. Hey, Not Prof, thanks for coming on by. Now we've got people coming online here hanging out with us. This is fun stuff. Not Prof actually is a prof, not a prof. I'm sure it's some sort of pun. He teaches math over at some other school that I can't forget right now, or I don't remember right now. I know this little view here. I don't have my second monitor because I'm in person on campus here. So it's fun like that. All right, I'm distractible, I'm sorry. So array lists are fantastic in that they can be resized. I don't need to tell it what size it is. I can just add to it essentially unlimited out to infinity. Not, eventually we do run out of memory and it will just crash. If we keep asking the operating system to store like millions and billions of things, we'll run out, right? But I can probably get a good million numbers in here without too much trouble, right? 4 bytes times a million is not all that large amount of memory, right? We have bytes of memory, we have kilobytes of memory is about 1,000 bytes, we have megabytes is about 1,000,000 bytes, and we have gigabytes is about 1 billion bytes. So at 1 million integers, we're not even at a gigabyte of memory for Java to store. Okay, we can probably get up to that without too much trouble. Our computers have decent amount of memory, and we're kind of spoiled. So to add then, the notation is different. We don't say this square brace notation. We say array list number dot, and you have a couple methods. You have add a value here, or you can even add at a given index. So if I already have 10 values, I have indexes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 for all my 10 values. I can say, oh, I want to add another thing, put it here at index 4. It will put it at index 4, and everything after 4 will slide down 1. And then I'll have indexes 0 through 10 because I have 11 items. So it's pretty cool. I can put it anywhere I want. It will do the shifting for me. If we have a regular array, we can put something at an index and do all the shifting, but we can't expand it very easily. Right? There's no way for us to expand arrays once they're sized. It's make a new array, copy things over, and then use the new bigger array, which is a big pain. When you get to the data structures course, 2353, you'll have all sorts of fun doing that by hand. And then you'll learn, oh, hey, the Java library Arraylist does it for you, and then you cry. No, there's the meme joke that goes around. So like name a book that made you cry, and the funny joke, I see it all the time because I'm a nerd, is Data Structures and Algorithms Analysis is the book that makes people cry. Like instead of, I don't know, like some sort of sad novel. Though I like data structures. I always thought they're really interesting. Yeah, so array lists know how to do the memory allocation and deal with getting everything in the right block of memory, contiguous block of memory. Because when we dealt with arrays, we said all of these values are stored in one chunk of memory, one contiguous block. So wherever that memory address is, times the index, times the size of the object, is where do you go read it. So the 0th item is at the starting memory address, and that's why we are zero-based for our first value, right? Because it's at that memory address. So if numbers says, okay, you now have the room for 10 integers, I will give you 40 bytes of memory here. Whatever index you want, I just jump that many times 4 bytes, because that's the size of an integer, and I have immediate access to those values. Arraylist does the same thing, but what it's actually doing is oversizing and then resizing and copying behind the scenes for you. It still has stuff in a contiguous block of memory. But let's add a bunch of values. We'll say random equals a new random. Oh my goodness, equals a new random. And then for int number is 0. I can't type, my fingers are just not, like they don't want to do the thing. Number is less than, let's do 100. Number plus plus. We'll take int random number equals new equals random.next int. And what do you want to go up to? You like up to 1 million or something for fun? Just a bunch of random numbers. I love you can use underscores. That is super helpful because I can never spot the zeros by eyeballing things. So up to 1 million will give me 0 to 99999, right? Not 1 to 1 million, right? So if you want 1 to 1 million, you have to add 1 to it. We'll do that. And then I'm going to take my array list of numbers, and I'm going to add the random number. So we'll add 1 million random numbers at our import for random. And then we're done. We can loop through. So you can do the exact same enhanced loop, right? This for int number in values thing out of an array list that you can in an array, which is fantastic. So we can say for, I want it as an int. So Java is good at converting integer, capital I integer, to lowercase I int. It does it automatically. The technical term for that is boxing and unboxing, where it converts or between whatever one that it wants. It's really smart at that. I'll say value colon my array list numbers. And we'll just print out the value. Oops. So the value. So we'll generate 100 random numbers, and I'm just going to go spit them out here. Give that a run. We should get 100 random numbers, 1 to 1 million. There we go. Those look like 100 random numbers. They're all relatively large, right? Oh, that was 20,000 or so. Here's 544,000, so 980. I don't see anything like in the single or double or even triple digits, but you know, most of your numbers are going to be, there's 100 or 900,000 numbers that have 6 digits in here versus less than that have 5 or less. So I think the odds of that work out. We're going to get mostly large numbers. Cool. So we get some numbers here. Now we could do the same thing. We could like ask them, hey, how many numbers do you want? And add as many as they ask for. Sure. Can do all sorts of fun stuff with that, but all we need to do is call add, and it will throw it to the end of the array list. It just keeps always adding to the end, adding on the end, adding on the end. That's the default. If you want it at a different index, you can tell it add, comma, the index that you want it to go to. So we could say, oh, if we always wanted to add to the front, we could add to index 0 every time. Sure, if you wanted, or add at any location. 1 in 1,000 are in the double-digit range. 1 in 1,000 out of 1 million? Okay. I can't do that math that fast in my head. This is why we have a math prof in the chat. So if you don't want to use this enhanced for loop, if you want to be able to change values, remember this is still a read-only loop, right? We're getting out the value. We can't change it inside the array list, just like we can't change it inside the array. So if you want to, we can use the same index notation. We can say for index is 0, index is less than. Now we don't have a length property. We have a size method. So it's arraylist.size instead of array.length. So array.length here or arraylist.size here. Again, just slight differences between them here. And then index plus plus. To then get a value out. I don't say ArrayList index of an index value, right? We don't use the square braces. We say get. We say get from the index. We can print that out. So this, regular loop using index. So the couple differences, right? You go by size and you use get on the array list because it's a class. We're using methods here instead of this straight index notation. That's all. So we did one of that. This, like with this loop, right? Off of the length of an array, same idea. We still go off of the size here, which is still the number of items in it, right? So it knows. So array lists are fantastic. Fantastic. You can remove items from array lists as well. I can take my array list of numbers, I can call remove, and I can remove a given index. This one's a little funny here. So remove, when we're dealing with integers, is screwy. It's going to try and remove the index value here. If you want to remove the item, remove it by a value, you can do that, but it's expecting the integer object type, not the integer lowercase I value. It's a little bit funky here with this. So this remove will remove by index. Moves by index. So like this will remove the first item in the array list, everything else will shift down. If I wanted to remove by value, again, I've got them all random right now, so I probably don't have, I can't just pick a value and find it in here very easily. But I could remove array list number, remove, no, not add, I want remove. I would need an object here of remove the value 1. This is really screwy. Suspicious call to collection remove. So removing is a little awkward, but you can do it. When we're dealing with array lists of integers, it's trickier. If we had like an array list of strings, that would be a little easier. So I can say array list of string. We'll call this our shopping list equals a new array list diamond parentheses. And you have to use the diamond and then the set of parentheses because this is the constructor call to the ArrayList class here of a given type. But now I can loop through my shopping list, right? We can take the little loop that we did. So, a string for item name. We're going to say just empty for now. And while item name equals ignoring case stop. And while it does not equal stop, let's keep on going here. We'll ask them, enter a name or enter an item for your shopping list or stop. And then if the item name does not equal stop. So the sad thing about using this sort of sentinel value is I need to go check for it one more time. So if it's not stop, then I can take my shopping list and I can add the item name. Right? Because I'd have to check one last time before this happens. The way you can get around that is by asking at the end, but then you're going to add the initial one. So either you have to ask twice or you have to check twice, which is a little bit sad, but it's not too big of a deal. And we'll say our item name. Right here. So this is where it was. Item name equals keyboard.next line. Oh, we don't have our scanner yet. Scanner. Keyboard. Where do we have keyboard in here? I think we used a scanner somewhere, right? Do we not use a scanner in here? Yeah, there it is. There it is. Let's move that up a little bit. All right. So just keep on asking, so we can keep on entering values into our shopping list as much as we want here. And then with our shopping list now, shopping list, we can call remove, and I can remove a string like remove beans from my list here. And it will remove the beans from the shopping list. Coffee, yes, Professor Perp, I do need more coffee. I should get more coffee. All right, so item for our shopping list, right? Let's add coffee, more coffee, donuts, I don't know, what else? Espresso, and then stop. So notice we called remove beans and nothing happened, right? So if you looked, let me stop that real quick. The remove method here tells you, find that again, shopping list remove. So remove an object will give you a Boolean value of true or false, right? Whether or not it was removed. This is that little like helper text here. If it was removed, we get a true back. If it didn't remove anything, we get back a false, nothing changed, right? So you'd have to check to see, hey, did we actually take this thing out of our list, if you cared. If you remove by index, it'll actually give you that string value back. Okay? This was the string at that index you just pulled out, by the way. But this works a little bit nicer, right? Because beans is not an integer, so it's not confused removing by integer index versus removing an integer value from our collection here. So this is just awkward only when you're using integers to remove something by value. More coffee. Cool. So all sorts of fun things we can do with array lists and arrays. It's going to take some practice, and that's okay. The big thing is using index notation for arrays, and we still can use indexes with array lists, right? But we use get for that. And then if you wanted to set a value at a given index, right? If I said, hey, change the value, it's set. Set. You say set what index, what value. So set index 0 to, I don't know, let's set it to like 42. So set method instead of array index equals value. Right, does that make sense? Like we would say whatever my array was at index assigned to the value, we use set to change the value. We use get to get the value rather than, where do we get values out? Like, hey, the number here, get this index or get this index. All right, so just some differences between the two. So it'll take some flipping back and forth. I almost always prefer array lists because they're more flexible. Right? I don't need to know the size ahead of time. I can just add to as much as I want. I can remove things from when I'm done if I care to. Arrays are still very common if we know what size they're going to be. Right? If we know, oh, I'm only ever going to have this many things, great, we'll use an array. It's really easy. Not too big of a deal there for that one. All right. Cool, so this will take practice. We'll do a quiz on arrays and array lists. I'll post that one. I'm gonna remind myself, array list. And looking forward here, because we're not covering the entire chapter on input and output, and we're not covering the entire chapter on exceptions, we're gonna have this quiz on arrays and array lists, and then only one more quiz after that, and we can call quizzes done for the semester. Because we don't cover the whole file IO chapter, we don't cover the whole exceptions chapter. We'll do the last quiz on Java FX there from chapter 17. We should be in pretty good shape. And then I will drop your lowest quiz score as well. I have to go change. I set that somewhere in D2L. I'll go set that to drop your lowest quiz score. I don't usually tell people that early on because then, I don't know, maybe I guess that's silly that they would say, oh, I don't have to take this quiz, I'll take that one as my drop, rather than at the end like, oh, hey, cool, I get a drop one that I didn't really care about. I'd rather you take them all than just take that freebie early on, but maybe that's silly, and I should just tell people. All right, should we take a break and then get into file input and output, and then the fourth project? right, should we do the regular 10 minutes? Cool. All right, we'll take a break, put on some music. We'll come back in a little bit. Thanks for hanging out with us online. So break puts us at 11:13, I think. Alrighty, welcome on back. All right, we got two last things to do then. We're going to talk about file input and output, and then we're going to talk about the last project. So we're not going to finish file input and output. We'll get enough of it done that you can get a start on the project, and then we'll finish it up come Monday. So we won't tackle everything yet, but enough to get you started here. So this is file input output. So the idea with file input and output, or file I/O, is that we finally now have a way to deal with data that is going to be around longer than when the program is running. Everything that we've done so far only happens while the program's running, because we're storing it in memory, in our RAM. Right? So we temporarily store it here, and then when the program stops, Java gives the memory back to the operating system. Says, okay, we're all done, you can have the memory back. Go use it for another program. So it's just there while running. When we can deal with files, we can write stuff to disk that will stay there. That's the idea with the disk. That's our long-term storage. So file I/O, reading files in and writing files out, input and output. Anytime we're dealing with files, we're going to do three things. We're going to open it, we're going to read or write to it, and then we're going to close it. Now, the closing happens automatically when our program stops, but you don't want to rely on waiting for your program to stop, especially if you're going to be using that file again later. If you don't close it and you try and go use it later, it's going to be in a weird state, because the operating system is going to think you still are using it, and it won't let you open it again, or you'll overwrite stuff and it'll be unhappy. So you always open, read, write, or close. So if we want to write to a file first, that's probably the easier route here. It's actually pretty easy. We use this thing called a print writer. So print writer, and we'll just call it something like my print writer or something, equal to new print writer. And then all you need to do in the constructor is you tell it what name of file you want. So I can say like test.txt. Now when it comes to files, this extension part here, .txt, is just a convention. It's so that your operating system knows, oh hey, it's a text file, I probably should open it with the text editor. I could name it .doc, and your operating system will say, oh, that's probably a Microsoft Word document. Do you want to open it with Microsoft Word? It's not a Microsoft Word document, though. I'm going to put text in it. So file extensions are just conventions. Right? There's no hard and fast rule, but for now, we're just going to put everything as a text file because that's nice and easy, and our files are text-based files. But I could put, .asd, some gibberish here. The computer doesn't care. Right? It doesn't matter to the computer what the file extension is, but when you try and open it, it's going to say, I don't know what this is. What do you want to open it with? So to make things easy, we're just going to say txt. And then we have to add some imports. So we're going to add the import java.io.printwriter, and then it's still mad at us, and it says, oh, hey, an unreported exception, file not found exception must be caught or declared to be thrown. You say, oh, okay, I remember this exception thing. So I'm going to put it inside of a try-catch block. So we're going to try to do this, and we're going to catch a file not found exception. This logger stuff is nonsense. You don't want any of that. And if we get that exception here, the easiest thing to do with that, back that out, sorry, is let's just print out the exception. And you just print the exception. We'll say, hey, catch that exception. I'm just going to print it out if we got a message here. Usually for writing files, this doesn't happen. If your programs run in some sort of network environment, they might happen because you don't always have permissions to create files in weird network environments, depending on where your program's running. On your local computer, if you can't make a file, something screwy happened, right? Because you should have permissions to make files. No problem. Once we have the print writer, so this is open, then we're going to write to it. And then we're going to close it. So I always forget to close things, so I try and do that first. So I'm open it, and then I call close. Printwriter.close, or whatever we've called our print writer here. We're going to close it when we're done. This is just so I don't forget. Again, it will close when the program finishes, but it's always better to be explicit and close it out here. And now to write to our file, it's actually really easy. We say a print writer, and if you put dot in here, you'll see there's a bunch of println, just like system.out.printlines. It's the exact same thing. We just hand it anything we want to print here. Like, hi there, file. We give it something, it will print it, it will add the new line character at the end, and we're good to go. And we can add as many prints as we want here. right? Eric, you're a nice file. I don't know. I'm running out of clever things to, that's not even clever, but sure. So we'll write three lines to it, and then we'll close it. So we give this a run. Now, I don't think that actually built. I had this last time. This compile on save is the worst option ever. You need a way to, probably there's a way to turn that off by default, and I just haven't Googled it. And one more time, let's run it. So if you just give it the name of a file, it's going to create the file in whatever directory the program was run in. So all this stuff that happens back here, right, is saying, oh, hey, we have all of this cool stuff happening inside of our file input-output folder. Right? This command that ran up here, this ant command, is kind of the magic. So this is telling Java, go do all these things and run, please. So where it runs is in this folder, file input and output. That's where the file is going to get created, inside of this folder, because that's where this command is running. So if I go and find it, there's no shortcut, which is really sad, in File Explorer. But you can go and find your Documents folder, find your GitHub folder, find your CIS 1500 folder, find your file input and output. Then we'll see test.txt. Again, it's a text file, so when I open it, it should just open in Notepad. That's generally the default text editor. You can open it in any tool you want here, but it's fine, we can open it up. The other easy way to go find it now, in NetBeans, usually we're in this project view tab. That's my favorite view. But you can also be in the file view tab, and it'll open up your projects as files. And if you look at your folder, you'll see test.txt is inside of there. So I can open up the file inside of NetBeans and look at it as well. So this way you don't have to go out and find all your folders in File Explorer. The only downside is then you have to go back to the project view if you want to see the project view. So you're kind of flipping back and forth between tabs, but not the worst thing in the world. So I can see my file here. So that worked. Now, if something bad happened, right, we'd catch the exception, print it out. No big deal. Again, probably nothing bad is going to happen. Not too big of a deal here. But what we might want to do, right, we might ask the user, scanner keyboard equals a new scanner, ask them, enter the name of a file to save your shopping list to, and we'll have a string for like the file name is keyboard.nextline. Oh yeah, add our imports. Yes, please. Come on, scanner. So when I make my print writer, instead of test.txt, I can say, hey, you now are file name. Whatever they type in. So any file name they give me, I'm going to try. Right? And then instead of writing out one line at a time here, we'll ask them. We'll say, I don't know, a string for item name equals nothing. And while I should just copy, I don't have the other project open. I think that's fine. Item name dot equals ignore case, ignoring case, well, does not equal stop, right? We'll ask them, enter the name and item to add to your list, or stop. We'll have a string for the item name, is the keyboard.nextline. And if it's not item name, oops, we don't need to tell it's a string again. And if it's not stop, we can take our print writer and we can print line, print ln, the item name. Right? Keyboard. What's wrong with this? Oh, system in. Goodness, I know how to use scanner. Done that before. Keyboard. Okay. So we'll ask them, hey, where do you want to save your shopping list to? What's the name of the file? And keep on giving me items. Let's try it. So what should we call our shopping list? Should we call it shoppinglist.txt? Shoppinglist.txt. Now, if they don't remember to put in the txt and I just say shopping list, we're going to make a file named shopping list with no extension. That's fine. The computer doesn't care, right? So what should we add to our shopping list? Coffee. Of course, coffee. What else should we add to our shopping list? Apples. Bananas.
I mean, we mentioned beans before. Let's put a bean.
Beans. Stop. Sure. So now in my file view, I have a file named shopping list. There's no extension here. NetBeans is really good about letting me open it. If I look in Windows and I try and open up my shopping list, it's going to say, well, you want to do with this? Because Windows has no idea what kind of file it is because there's no extension. There's no convention to follow. So we can tell it, oh, hey, use Notepad, please. Right? Sure, we have all the stuff. So sometimes they're not going to put in the extension. Well, that's fine, right? We could do things if we wanted to, or we could add our own .txt, right? We could take file name plus .txt if we wanted, or do any sort of thing like that. Doesn't matter too much, right? The computer doesn't care if you use extensions or not, right? If you look for one with an extension and it's not there, right? Just know we didn't add it in. Not too big of a deal. Okay, so that's not so bad, right? We went and wrote our file. Now, how about reading a file? Can we read a file? We can read a file. Yes, we sure can. So let's come down a little bit here. And let's ask them, hey, enter the name of a file to read. And we'll have a string for file to read. Keyboard.next line. Now, reading files takes an extra step. So writing is pretty easy with PrintWriter. Oh, I did actually wanted to show you one more thing real quick, too. If I run this again, and we use that same file name, we use shopping list again. We say shopping list, and I say ASDF and stop. And we open up shopping list. Everything is gone. So PrintWriter is going to delete the contents of your file when you tell it it's a new PrintWriter. Anything that was in it, gone. So be a little careful, right? That we don't blow away things you don't want to blow away. So this PrintWriter will erase anything in the file. Okay, gone. There is a way to make it append to the file we'll look at in a little bit, but for now, we'll save that for Monday. So this is enough to get us by. We'll look at how we can not do this on Monday, okay? But just keep that in your back pocket. Anytime you call PrintWriter on a file, it's gone, right? Starts off brand new from scratch. Okay, so for a file to read, we're going to do two things. The first thing is you make a file. The second thing is you open it. So a file is actually, there's a class named file. So this is the file to open equals a new file. And you give the file class the string of what file it should go open. And yeah, we need to go add the import for file. Now the file class is really cool and really smart because it can tell you whether or not there actually is a file there. So we can say if file to open, exists. So if it exists, we can go do something with it. If it doesn't exist, we can tell them is no file named plus file to read. Right? So if you're asking the user for something, I mean, even if our program's running, we might have typoed something. So we can check with the file class and say, hey, does this file actually exist? Is there a file before I even try and open it here? Otherwise, we're going to crash. And, that's okay. We can catch the exception and print out an exception, but that's okay. So 2 ways to do reading. I want to show you what I think is the easier way. And then on Monday, I'll show you the book way, which I think is the harder way. I don't know why the book uses this route, but that's fine. Turns out to read a file, you can use scanner. The same thing we've been using for keyboard input. So we're going to open the file. We're going to read the file. And then we're going to close the file. So to open the file, we can use scanner. We'll call this maybe like file reader equals a new scanner given the file to open. So if you hand scanner instead of system in, if you hand it a file object, it's more than happy to go read that file, which is super cool. Now it's telling me, oh, hey, there might be another exception happening here. So we're going to, don't do Okay, there's only one option. Sometimes there's two options for this try catch. One is like surround everything, and one is surround statement. Surround statement is the one you want here. And again, this logger stuff is garbage. Forget the logger stuff. It's not garbage. It's really good stuff, but it's not anything we're going to bother with right now. And we'll just print out the exception. Now, file not found exception is if you try and open a file and it doesn't exist, you get a file not found exception. Right? We can already check for that right here with our if the file exists. Which, if you can deal with this with a simple if-else, this is always better than dealing with an exception, because the exception process is actually slow. It interrupts the regular flow of a Java program, and other stuff has to happen, so it's much slower behind the scenes than a quick little if-else check. It'll still work, but the better form is to do a quick little if-else check instead of waiting for this exception to happen and catching it. All right, so we're going to open it. When we're done, we're going to close it, because I always forget to close things, so filereader.close, and then to read the file. Now, I don't know what's in the shopping list, right? I don't know how many items you had. So I'm going to read them all out, and we can just print them, maybe, or we can put them into Arraylist for use later, or all sorts of fun options we could do, right? Do you want to just print them out for now? That's the easy way? Okay, we'll do that. So to determine whether or not there's something to read, we can say while my file reader dot has next. This means, is there something next for me to read? If it's true, I'm going to go do it. As soon as there's nothing left to read, then my while loop will stop. I'll be all done. So here I'm just going to print my file reader dot file reader next line, right? Just like scanner works, you can say next line. We'll get the entire line out of the file, read one line at a time. If my file has 100 lines, this while loop will run 100 times. If it has 2 lines, it'll run 2 times. If it's empty, it'll run no times. Okay, so let's give this a run. So the name of our shopping list, shoppinglist.txt. I'll be nice and add the txt this time. We'll add coffee, we'll add apples, and stop. All right, what's the name of the file to read? How about the test.txt? Test.txt. We get, hi there, file, my name's Eric, your nice file. Right, that was what was in test here. Right, the shopping list had coffee and apples. This shopping list had ASDF. Right, great. So we can go and read files. Right, just keep on reading that information out until we're done. That makes sense for scanner? Cool. The last bit here. So if we know the particular format of a file, right? If we know, hey, the first line is going to have the name of something, and the next line is going to have the quantity of something, and the line after that is going to have, I don't know, the color. We can come up with all sorts of funny things. We can write things in a specific order and then read them in a specific order. Right, so we had in our, oh, I closed that one already. Like if we wanted to have a class that we're going to write all the data out for, we could write one line at a time per attribute, or we could put it all in one line if we wanted. We got different options for how we can write classes out to files in a text-based format. Let's, what do I want to do? I think that's fine. Did shopping. I'll just add another file here. So let me come and add a new file. New other. It's not like a plain file. I think it's an other, right? Empty file. There we go. We'll call this numbers.txt. Like 10, 20, 50, 100, 1,000. Sure. I'll put some numbers in here. So if we were to go read that number file, right? I can have an int for sum, or start it off at 0, and then we're going to do this same sort of thing again. So we're going to essentially do all of this here again. Call this my numbers file, numbers.txt. And if the file exists, let's open it. We'll call it file reader. Again, this is fine. We'll rename it all here. If we have next. So let's get that value out and turn it into an integer. right? So I'm going to have an int value is integer.parseInt of the file reader next line. Right? Just like we were asking for keyboard input with scanner, get the next line integer.parseInt. We're going to do the same thing off of the file data. File reader, there we go, file reader, next line. And I'll take my sum plus the value. When we're done, oh my goodness, next line. This is the file reader. Next line. Okay, file reader dot next line. Sorry, I had those backwards. And then when we're done, we can print out the sum of the numbers. Numbers in the file are, oh, that should probably go inside here, right? Because that's only if the file exists. I guess we'll do it inside of here. Plus the sum. Right, so we'll start sum at 0. We'll open up the numbers file, and then one line at a time, we're going to convert them to integer, add them to our sum. Not the most interesting thing in the world, but we should see 1,180. Right, I think it's when we add those up, 1,180. Give that a run. We'll say shopping list.txt, coffee, and stop. All we need is coffee. Shopping list.txt. Oh, uh-oh. A number format exception for input string coffee. Where? File input output line 77. I did the wrong thing here. I gave it the same file. My goodness. Numbers file, given the numbers file. Okay. This is why copy pasting is dangerous. I'm sorry. I opened the same file instead of the numbers file that I just made. That was a bad copy paste. Try that one more time. Test.txt. Everything should say coffee. All right, name of the file to read, test.txt. Great, we get coffee. Sum of the numbers, 1,180. Great, so it was able to read this numbers file, converting to integer one line at a time. That was sort of the idea here. So, and if you know what's in it, you can do the thing. Right? Go ahead and read it. Go ahead and read it. If we know there's only like 2 things, this loop here is a little funny. We could just read twice. We could say file reader next line, file reader next line to get out those 2 individual values. We'll look more at that on Monday when we deal with classes. But I want to get you far enough out to get this project done. All right, so let me do this here. I'm going to cheat. You guys are going to do the same project as the night class because we're essentially back in sync. We're going to do a couple more examples come Monday, but let me go export this out. This will save me a little bit of time rather than having to retype everything. I'm going to export. The project and the grade. Project 4 and project 4. All right, cool. Done already? Nope. There it goes. Let's download. D2L is a fun little system here. And import. I think this is faster than me copy pasting stuff. Oh, I didn't copy paste the rubric. All right, I lied. I gotta export one more thing. So, one more try. Now it probably would have been faster to copy paste it all if it would have done it right the first time. Got one last thing. Export. Assignment, grade, and rubric. There we go. All right, here we go. Project 4. Project 4. And project 4. Okay. Assignment, grade, and rubric. All three things. All right, export's done. Back to our class and import. That wasn't too bad, right? I said to do it twice. Watch, I probably forgot something again. One of those days. I forgot to be watching chat, folks. Anybody still around? Nope, more coffee. Nope, still just on coffee. That's where we are. All right, so we're going to import from downloads. Which one's the newer one? 58. That looks like the newer one. Give that a shot. That probably worked. Usually it's pretty decent at working. Let's give it a try. So, project 4. All right, project 4. Edit. So, ours is going to be due in 2 weeks. Right, that puts us out at November 17th. 17th, 10 a.m. Okay. It's worth 18 points. Should be linked to that item, right? Yep, the project 4. So each project got worth a couple more points each time, a couple more points each time. So our program is going to be 2 parts. We're going to be managing a store and letting people buy stuff from our store. So to manage the store, we're going to give them a couple options. They can manage an item, where we're going to ask for an item name, and we're going to go and look for a file with the name of that item. And then we're going to then update the price or quantity after telling them what the existing quantities are. So, hey, my store sells coffee. We're going to go look for a coffee.txt file and say, okay, currently coffee has a price of $1.50 and I have 20 of them left. Sure. Do you want it? And then I can go change either the price or the quantity or both. Right? I'll tell them what it currently is, and I can enter a new price, enter a new quantity. I can add an item, ask for the name, price, and quantity, makes a new file with the name of the item plus txt, writes the price and quantity to the file. So pick one to write first, right? Write either price first or quantity first. So then when you go read it, you know the first one is price or the first one is quantity and the next one is the other one. And also an option for remove, which deletes the file. To delete a file, we're not actually going to do it here, but if you have a file object, you can say file to open.delete. That will delete a file. Right? Nice and easy, which is really cool. So you make a file and then go delete it. You probably want to check to make sure it exists first as well. Right? If you delete something that doesn't exist, it'll be a little unhappy with you. So that's the manage the store. So the idea here is that every item will have its own file. So if I sell 100 things, I'm going to have 100 files. If I sell 2 things, I'll have 2 files. So as you make more things to sell, you'll generate more files and more files and more files. So they can manage their inventory, essentially. When we get more apples in, we'll go and update apples and change the quantity and maybe change the price if we care. Right? Whatever options we want to. And then part 2 is we're going to sell stuff. So when the program starts, like ask them, do they want to manage the store or go like into kiosk mode or sales? I don't know. Like, do you want to sell stuff or do you want to manage your inventory? You don't need to be able to switch between the two. If they pick manage, just do the manage stuff until they're bored. If they pick sell stuff, go do the sell stuff until they're bored. Right? And then they can run it again if they want to get to the other mode. So in sell mode, we ask them to enter the name of the item they want to buy. We're going to look for a file with that name. So they can enter anything they want. Hey, do you sell PlayStation 5s? We'll go see. Do we have a PlayStation 5.txt file? If not, we tell them, nope, we don't do that. We don't have that for sale. If it is, tell them the price and the quantity. Ask how many they want to buy. Right? Oh, sure, you have PlayStation 5s? I'd like to buy 5 of them, please, because I'm going to scalp them. I'm going to make some money for Christmas. Don't be scalpers, please. They're terrible people, by the way. If they say, hey, I want to buy 100 and you don't have 100, tell them they can't do that. Right? I don't have that many to sell. If you do have enough, tell them the total price, right? Quantity times price, and then ask them to enter some payment information. Just, it's a fake prompt, pretend it's credit card information, Bitcoin address, I don't care, right? Just enter something, Doesn't matter. They just enter something, right? We're just pretending. Thank them for buying something at your store. Allow them to keep buying more things until they're done. If the file doesn't exist, tell them you don't sell it and allow them to keep buying stuff. Right? Remember, always be upselling. It's ABU or something. Always be upselling. I'm sure there's an acronym for that. That's the idea. So we're doing everything with files. Now, there's a way to do it with a single file that I think is actually probably harder, and especially because we haven't done the binary format. So we're going to do one file per item. I think would actually make life easier for you. Does that make sense? So then in terms of a rubric here, look, it did attach. Yes, 18 points here. So 2 points per item here. 2 modes, manage item, shop mode. Manage item mode, you can add new items where you create a file with the item name.txt, the quantity and the price. You can update existing items. So I gave doubled up on this one. So when you go to update something, we tell them what the current quantity and price are. And then in update mode, we can add new values for quantity and price. So 4 points there for updating items. And then in manage item mode, you can delete something. 2 more points for that. So 8 points for being able to manage items here. And then 8 points in shop mode. So shop, they can attempt to buy anything they want. We're going to see if there's a file, right? If we have a file, hey, yeah, our store sells this thing. If there is no file for that, nope, sorry, we don't sell that. Right? If it does exist, display the price and quantity on hand. So go read the file. Then ask them, how many do you want to buy? Make sure they don't buy more than the quantity. Ask for the pretend payment information. And then allow them to keep buying things until they get bored. The piece I just noticed is missing here, I'm recalling now, is when they do buy something, we need to change the quantity. Right? If I have 10 things and they buy 5, I need to change the file to make sure I only now have 5 left. So I'll go update that in a second. But that's it for the project. That make sense?
So from the beginning, when it asks you if you want to manage the store shop,
Mm-hmm.
and then when they choose an option, are they allowed to go back to the other mode?
You don't need to bother with that. So once you're in manage mode, just let them manage things until they're bored. Right? They can add, they can update, they can delete until they're all done, and then the program could just quit. If you want to go back and like, hey, do you want to be manage mode or shop mode or quit? That's fine. It makes your menu a little bit more complex, and we don't really care that much at that point. Let me go add that here. So shop mode. Update the quantity on hand in the file. Okay.
So we have to like pick a theme for our store and like add a bunch of things already in the inventory?
You're welcome to add as many things as you want. The thing I care about is the code. So if you only ever try it with one file, that's fine. Right? Don't feel like you need to go add a bunch of things, because I'm not going to look at your files at all. But I'm going to run manage mode. I'm going to add a file to sell, or add an item to sell, and I'm going to go see if I can buy it.
How would you know, like if we were like a brand new person going into sales or into the shop mode, to know what to search for?
You just try your luck. Yeah. There's ways that you could, and the book actually goes through an example of like, hey, open up a directory and give me a list of files out.
Yeah.
We don't care. That, again, it's probably something you'll tackle next semester. That's a little more advanced. So they have no idea what's for sale.
Yeah, I was gonna say, like, how do they know if I'm selling like screws or wood?
Yeah, there's no way of knowing that. Being able to list out files is, again, a little bit more complex. That's something we would probably tackle next semester. There's ways to do it that aren't too tricky. Like in the book, we'll show you, hey, you can open up a directory and find every file inside of it and get the name of every file, but again, that's more than we care at this point. So I need to make sure I tell the Tuesday class to fix that thing too, because I forgot to put that in the rubric. All right. Any other thoughts, questions, concerns? Again, we'll do more on Monday. We'll look at using a class to represent something and writing that class out to a file. We'll have a lot of fun with that. You don't have to use classes for this if you don't want to. I think it would make life easier, but again, I'm not going to require it. We already did our project that required classes, and the final project will require classes, right? Project 3 required classes, right? Yeah, and tests. Yeah. Okay. I'm going crazy here, folks. So, cool. So we'll have more time on Monday to work on it. And then Exceptions will be a light chapter. We're not going to do a whole lot with it. I want to show you what we should do in classes with exceptions. But that's a topic you'll dive deeper on in 2151 if you continue on in the next programming course. So it shouldn't take us a lot of time. We should have some good amount of time to work in class on that. So I think we should be in pretty good shape for getting this one done. Okay? Cool. Don't forget tutoring sessions, Tuesdays and Thursdays. Today's Wednesday, right? So tomorrow, 1 p.m., or schedule individual appointments, and we can go from there. All right. Thanks, everybody, who's hanging out online. Is anyone around a raid? I don't know if anyone's actually online. Yeah, man. Oh, Professor Peter's online. We'll go talk to another math prof for fun. I think it's Prof. Peter. Yeah, there we go. All right, everybody online. We'll head over that way. Have some fun. Tell them hi. And I'll see you around.
Bye.
Take care.